Alright, so we're going to start with a few pictures all describing the same thing. This is the quantity 2/5. It's the amount each child would get if you had 2 pies split amongst 5 children. So here's the way that we've been using with the circle. Fairly straightforward. Then what if we had like a rectangular pizza and I cut them this way, into 5 pieces, and then I'd give you 2. That's how I would give a portion to a child if I had 2 pizzas total and 5 children to split it amongst. Or if I cut something into 5 pieces and took 2 of them. And then here, maybe I cut them this way and I give them columns. So these are all different ways to denote 2/5. So quick introduction to a different format for representing fractions so that we can continue with the idea of multiplying fractions. Real quick, the word of means multiply. So if I want to have 2 groups of 3 apples, I would have 6 apples total, right? So it's 2 times 3. If I wanted to find out what half of 10 is, it would look like this. 1/2 of 10. And I know we haven't talked about multiplying fractions yet, but this is to convince you that the word of means multiplying. And so if I wanted to find out what 1/3 of 2/5 was, it would look like this. So how do I find 1/3 of 2/5? This one we talked about a little bit before. I can split into 3 times as many pieces. But let's do this problem using a picture. So I have the prerequisite knowledge that 2/5 looks like this. 1, 2, 3, 4, 5. And if I wanted to draw that a little bit better, just as a tip if you have to draw diagrams in front of students, a good way to do that is to split it in almost half. That'll be 2. And then now the bigger side is going to be split into 3. And hopefully that's a little bit cleaner. Okay, and now I have 2 of those fifths, so I'm going to denote that by shading this in. And now I want to find out what 1/3 of those is. So it was nice to break up this rectangle into 5 this way to look at what 2 was. I've already used up this edge, but now I want to consider breaking it up into 3. So I'll use the other edge to break it into thirds. So now I've broken it into thirds. It doesn't have to be so long, I just did that to emphasize it. So this is my new diagram. And now I want to only take 1/3 of what I had before. So now I've split what was allocated before, and I've split it into 3. And so I can look at what 1/3 of that would be, and that would be this much, 1/3 of the shaded region. So now I can see what that is. Well, when I broke it into 3 this way, I originally had 5, and now I made 3 times as many, because I broke each one into 3. So I now have 15 boxes here total. So if I just was not looking here, but looking at this picture, I have some amount shaded out of 15. How much is shaded? 2 boxes got shaded when I did the multiplication, when I considered what 1/3 of it would be. So there's 2. And if I look here, if I multiply straight across and multiply along the bottom, it is 2/15. So what's happening is I have 3 times as many squares. So I have 2 boxes still out of I had 2 columns. Now I only have 2 boxes, but I have 3 times as many boxes. All right, let's try one with a little bit different numbers. Okay. So let's say 4/7 times, let's say 3/5. Okay. Well, I'll start thinking about what 3/5 is. I can start with 4/7 or 3/5 because multiplication is commutative. So I'll draw my 7ths first. So again, I'll break it in almost half. And then the top will be my first 3 things. So it's less than halfway there. And then this one will be 4, so I'll split it in half and each of those in half. And this should make a pretty well-spaced 7. Okay, and now I only have 4/7. So 1, 2, 3, 4. Okay. Now, I've broken this into 7ths this way, and now I want to take 3/5 of it. And I could have done the 3/5 first and then done 4/7 this way, doesn't matter. So, now I want to break this into 5ths because I want to take only 3/5 of the 4/7. So I'll break this into 5ths, so I'll use that technique of going, oh, I should use a different color. Of going a little less than halfway. And that will be my first 2. And then this will be broken into 3. And hopefully that's pretty even. Better than just going left to right and hoping for the best. Alright, so I've shaded in those first 4 this way. And that'd be hard to see, so I'll do it again. Remember, I shaded in this, 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 and this. That was my 4/7, my 4 rows. And now I need to think about what 3/7 of them are. So I broke it, or sorry, 3/5 of it is. So I broke it into 5. And now of the portion that I have, I'm only going to get 3/5 of it. So I'll be getting 1/5 of it, 2/5 of it, 3/5 of it. So now I have this corner representing what I have. And hopefully this kind of reminds you of the area model for multiplication. So I'm going to go how far? This would be a 1 whole amount, going 1 whole amount, because this is of length 1. So this is a 1 by 1 unit square. And I'm only, instead of having like 2 by 3, so like 1, 2, 3 groups of 1, and then 2 groups of 1 like I had in the area model, I'm only looking at one box and I'm only shading in a percentage of it each way. And now I'm looking at what I have instead of looking at the whole way. So this should help you connect it back to the original area model, but instead of going 3 long this way and 2 long that way, I'm going to look at a 1 by 1. This should be more square than it is. And I'm going to only take a portion of it this way and a portion of it that way and multiply it and see what I get. So, how many squares are there? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of how many did I make? How many are there total? 35. So you can see why each multiplication happened now. So I originally had 4 rows, but then I split it into 5, and I'm taking 3 of them. So the 4 rows I originally had, I'm going to take 3 of them. So each one is a set of 3. That's my first row, second row, third row, fourth row. I just had 4 sets of 3 because I'm taking 3. So I have 4 sets of 3, and I have 4 sets because I had 4 columns, and I get to take 3 rows. So out of the 4 columns I shaded, I get to take 3 of the shaded rows, so that makes the 12. And then I originally had 7 pieces altogether, but I broke it into 5 times as many, so every original row became 5. So when I only shaded in 4, I broke it into 5 times as many pieces, and I took 3 of them. So for every row, I now have 3 pieces. So I have 12 total, because every row, there's 4 of them. I have 3 pieces. And then I originally broke it into 7 this way, and now I broke each row of the original 7 I had into 5. So it's how many I'm taking versus how many I broke it into, and that makes our numerator and denominator. Alright, now what if we had something, let's do one more like this, and then we'll do one that's a little bit trickier. So let's try 2/3 times 5/6. I guess. Alright, so I'll just do this one first. So I have a 1 by 1 unit square. Everything's of length 1. And now I'm going to look at what portion of 1 I get. So when I have a pie, right? this is 1 whole pie, and I look at what portion of it I get. Maybe I get 1/3. So now this is 1 whole pie, 1 by 1 in length. So it's a unit measurement. It's a unit amount. And now if this is 1, how would I denote 2/3? Well, I would break it into 3 and show that I have taken 2 of them. 1, 2. That's how much I have right now of the pie. And now I want to take a portion of this. What portion of the orange stuff do I want to have? Well, after cutting it into 3 and taking 2, now I want to consider what 5/6 of it would look like. So of what I have, I'm going to need to break it into 6 and take 5. So I'm going to break it in half and then break each half into 3. So I've effectively I've broken into 6 going this way. And now I'm only going to take 5 out of the 6. So of the shaded region I have, I'm only going to allow myself to go 5 out of the 6 as what I can claim. So 1, 2, 3, 4, 5, and I get 5 out of the 6. So all in all, how do I denote what I've just double shaded? That's again this region right here. Well, if I count them out, I'll see that there are 10 squares that have been double shaded. Out of a total, how many boxes did I make within this 1 by 1 square? 18. And again, hopefully you can see how the logic flows here. I had originally 2 columns, but then I broke it into 6 more pieces and I took 5 of them. So the amount claimed, I had originally 2 rows claimed, and now I'm going to get 5 columns claimed. So the amount claimed is now 10. And then the amount, out of the amount total, well, originally I had 3 columns total, and these 3 columns eventually turned into, each column got multiplied by 6, so now it's 18 pieces total. So these original 3 rows turned into 16 things, because each row, as I go down the rows, is now a value of 6. So 10 out of 18. And we can simplify that. Having 10 out of 18 is the same as having 5 out of 9, but we're not going to worry too much about that now. But if I took half as many squares and half as many, so if I took half as many out of half as many, then it would be the same as 5 out of 9. So I could reduce this picture down by erasing parts of it and see that it's equivalent to having 5 out of 9. Okay, so those were proper fractions. Let's deal with improper fractions. Let's say I had 7/6 times 2/3. It's a little different, because now, how do I draw 7/6? So I'm going to start with that same 1 by 1, so I was able to take like 2/5 of it before, or something like this. A 1 by 1, and now I want to take a denomination of 6ths. So I'll break it in half and break each half into 3. Alright, broke each half into 3. And now I have 6, and I would need all 6 of them and 1 more. So I'm going to draw like another 1 by 1 unit square. It keeps going. Imagine it going beyond the board that I have here. 1, 2, 3, and there's the start of my 4th column, but I can't quite draw it all. Let's try moving it up, actually. Sorry about that. So here's a 1 by 1. Here's a 1 by 1. Break it in half. Break it in half. 1, 2, 3. 1, 2, 3. 1, 2, and 3. 1, 2, and 3. Oh. So I have a bunch of 6. And now I'm going to take 7. So 1, 2, 3, 4, 5, 6, 7. Okay. And now I have to break it into 3 because I only want to shade in 2/3 of what I have. So break these into 3, and I'm only going to take 2 of them. So 1 row, 2 rows. I should have shaded all the way down. Oh, there's my 2 out of 3 that I'm getting out of the shaded region. now I can see that I'll erase the parts that weren't double shaded. I could have done that before with the previous problems. So this is what I'm having after I only considered 2/3 of it. So now the part that's shaded denotes the part that's claimed out of how many boxes. And I can now, instead of having to consider having 2 boxes, I can move these over here. And now I can count and see what I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 14 out of, well, I have 14 out of what? These are, so I don't need this box anymore. It was just there to help me out a little. 14 out of 18. And then you can see that multiplication does hold, that would work. All right, what if we had something a little bit different? What if I had filled in the whole thing? So it wasn't a problem because any excess on my bottom extra square, I was able to throw up back into the original square, and now I could just look at one square again. But now what if I'm stuck with those 2 squares? I'm not able to move it. So let's consider a case like that. So let's go with 7/5 times let's go 9/5 times 3/4. All right, so now looking at my board, I'm going to need to denote the denominator by my rows. And I already know that I'm going to need more than just 1 box. So I'm going to break it into fifths because that's my denominator. Okay, everything's broken to fifths, and now how many fifths do I have? I have 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. And now I need to consider the 3/4. So I still have a distance length 1 this way. So I'm gonna break it into 4, which involves breaking everything in half. So now 1 row is now 2 portions, and then in half again on each side. So now what used to be just 1 solid row is now 4 of these new portions. And now I'm gonna take 3 of them in. So 1, I shouldn't have it on my space, but 1 row, 2 rows, and 3 out of the 4 rows, or columns, sorry, columns. I remember columns because they say like the columns that Rome and stuff, so they were used to support buildings, so they go up and down. So those are my columns, rows go this way. Okay, I'm gonna erase everything that's not double shaded because that's how much we're actually getting. We're only getting a portion of what we originally were portioned. And now I'm gonna play that same game and fill in. Can I get a full square? Can I get a whole 1 pizza for myself and have some left over even? So I'll erase 1 here, fill it in there. And then erase another 1. Fill it in here. I'm gonna erase 2 more. Well, heck, I'll do 3 more. And now I can actually fill in that thing. 1, 2, 3. So now I can see what I have. The end result is 1 full column and 1, 2, 3, 4, 5, 6, 7. 7 out of how much is here? I have 7 out of 20. And another way to do that is saying each individual box is a 20th. And how many 20s do I have? Okay, I have 20 here and 7 more. So I have 27 20ths. Either answer would be fine. Okay, thanks for bearing with me. I would say the most helpful thing that you can have as a tool would be doing this, the first couple examples that we provided. Those would be the ones involving just two proper fractions, so I don't have to involve a second square. And remember, that's a square of 1 by 1, and you have to practice portioning out both sides and then seeing how much overlap there is. So that's going to be your assignments for multiplying fractions. All right, just pick two proper fractions and then draw the diagram for it and show the shading. Cool.